Welcome to C Programming. This is Dennis Hunchuk. I am your instructor for this course. I'd like to start out by talking about yesterday. There was confusion on whether class was yesterday or Thursday. Obviously, it was yesterday, Tuesday, and it's every Tuesday at 11:30. There was a glitch in the Canvas course under the Zoom link that said Thursday instead of Tuesday. That has been fixed. So I am recording this video because many of you were not in my Zoom session. And again, it's not your fault, it's mine. So this is your first class, and again, your second class is going to be on Tuesday and every Tuesday at 11:30 using the Zoom link right here. So let's just double check that that's correct. So the Zoom will be every Tuesday. So your next class is Tuesday, January 19th at 11:30 and so on. So all you'll do is come in here, click start, and you should be in the meeting. All right, so this is Canvas, and this course is going to be taught using Canvas. This is a mixed mode course, and if you'd like, you can click on this little link and read a little bit about mixed mode. A little different on a mixed mode, and I'm not going to read this to you, but basically what a mixed mode course is kind of like a half and a half type course. Half of it comes from you learning on your own online, and the other half comes from us on site. Don't be confused with that word on site. Because of the pandemic, on site means in Zoom. All right, so I'm going to leave this, let you read this on your own, and I'm going to move back into Canvas. So in Canvas, this is where everything is going to be done. You're going to click on We Are Here, unless you're new to Canvas, and then you're going to start way up top on the Canvas orientation module. All right, so some of the rules that I have in the class: no global variables ever allowed in your code, and you can click on that link and read about it, and then no using the goto command. So check these two links out. So let's talk about COP 1000 and COP 2220. You guys are in COP 2220. You all should have taken COP 1000. Just all should have. Okay, because it's a prerequisite. You should be familiar, hopefully, with Visual Studios. If you're not, you need to get yourself up to speed. You definitely should be familiar with what a design tool is. For example, an IPO chart, a flow chart, pseudocode, or structure chart. And the reason you need to be familiar is you're going to have to include a design tool with every piece of code you submit. I have a video out there about a design tool, so if you need it, go out to my resource site and watch it. You are going to be responsible for writing neat and well commented programs. Other topics, you should be familiar with variables. Now here's my problem. Some of you have actually had me for COP 1000 in the last 2 semesters, and I started beginning teaching it using Python. So my Python students are at a little bit of disadvantage because they're not used to C at all. But everything we learned in Python is going to transpose itself into C without a whole lot of extra work. The way we declare variables, for example, we have to give them a data type. In Python, they were auto data typed. You should be familiar with the if and the if else, and hopefully the switch. I will cover the switch because a lot of my Python students never saw a switch. You should be familiar with repetition, the while and the for loop, for example. That is across all languages, and C has something called a do-while loop, just like Java does. Definitely should be familiar with functions, writing them, using them, calling them. Hopefully you're familiar with a one-dimensional array. My Python students should be familiar with a list, which is very similar to an array. You should be able to pass values to and fro functions, and you should also be able to pass arrays to and from functions. Hopefully you have already developed good programming style and logic. You definitely need to be able to write, save, and submit your work in Canvas. And if you need any help, you need to reach out to me. All right, so that's what you should already know. This is what we're going to learn. One of the main topics we're going to discuss is calling functions, not just by value, which is what you've done up till this point, but also by reference. We'll talk about recursion. We'll talk about using a debugger. We'll talk about menu systems. We'll talk about how C handles strings. This word pointer, 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 and pointer, you will see that a lot. Pointers, major topic in C. We'll talk about error handling. We'll talk about text and binary file both input and output, we'll talk about something called structs, which is nothing but a user, let me rephrase that, nothing but a programmer defined data type. We'll talk about how to create structs, how to use structs for input, output, how to have an array of structs, struct. Then our next topic will be something called dynamic memory allocation. We'll introduce what's called a stack and a heap. We'll talk about automatic and manual memory. We'll talk about some new built-in functions such as calloc, malloc, free, and maybe even realloc. We'll talk about how to access this dynamic memory either contiguously or disjoint. We'll talk about pointers again, and again, throughout this semester, we'll use the term pointers. We'll talk about a pointer array, and we'll talk about pointers that point to pointers. And then we'll end the semester with something called a linked list. Okay, as you traverse the Canvas course, make sure you scroll down on each of the pages to make sure if there's anything down below that is important to you. For example, this is a little bit about design tools and so on. So down here, there will always be extra documents or actually images or possibly YouTube videos. So here's some basic YouTube videos from one of my previous colleagues, Dr. Colin Archibald. So depending on your level of expertise and what you remember or what you've been taught or maybe what you don't remember or have not been taught, you need to watch all or some of these videos. These videos that I have posted here will be basically COP 1000 in general. So if you need a refresher, that's where you're going to get it. Okay, I'm going to take a second jump. Okay, so what I'd like to do now is just basically talk about some terms and possible definitions. And this was actually my icebreaker that I did yesterday with those that came into the class. So again, if those that you missed, I apologize, but I'm going to do it now kind of on my own. All right, so the first slide would be a picture of what you see here. And I believe what we see here would be text editors. So there's notepads and Notepad 2 or Notepad++. And the reason I have a text editor on the screen is all your C programs are nothing more than text documents. And since they're text documents, you really don't need an IDE to create a C program, but I highly recommend it. But in case you have an issue installing your software, you can use any text editor for the first program. We will not be using text editors. We'll be using IDEs, Integrated Development Environment. And one of the IDEs that we're going to be using is Visual Studios, for example. Or you could be using Eclipse. You could use NetBeans. You can use Visual Studios 2019 Community. You can use whatever flavor of Visual Studios you find, or you can use Dev C++. It doesn't matter to me which IDE you use, just make sure you get one, install it, and learn how to use it. So IDEs will be something that you're going to need in this class. So my next slide that I used would show this SDLC, this image, and this image. And basically what this talks about is software development lifecycle. And developing software is cyclical. It starts with a need or a requirement from a client. Then there's an interview process and a designing process where we go back and forth with the client, and then we use our design tools to map out our program. Eventually we go to code it or implement it. We test that again over and over, possibly have to go back and redesign. After we have it coded again, test, verify. And again, this process is cyclical. So SDLC, Software Development Lifecycle. All right, so another major topic in this particular class, well, that is memory foam over here, memory foam, memory, RAM, and something called the stack and the heap. So this talks about memory. Memory is going to be a major component in this class, and the major reason it's a major component is C is a lower level language, and in a lower level language such as C, I can get all the way down to the lower level of the hardware system, and I can actually manipulate bytes and bits of memory or bytes and bits of storage. So it's definitely things that I can do in C that I can't do in Java or Python. So this particular slide talks about RAM or ROM, which is our two categories of memory: random access memory, read-only memory. Okay, so the next slide, these are binary numbers, binary plus file, binary files. So we're going to be talking about binary files, both input and output, and I'll just say that's a topic coming up. Binary files. Don't let that word scare you. It's not hard. Looks like that's just like a book or a bunch of text. Text plus file is text file. We will definitely spend time taking our output from the console into a text file. That's not just a dog. That is a special dog. That's a pointer, pointer, and pointer. So you might say, hey, how's this a pointer? Because that looks like an asterisk. As I said earlier, in C, pointer is a major concept. So pointer, pointer, and by the way, this asterisk, we should know that that is used in multiplication, but when we do memory allocation, that also could be pronounced pointer, pointer, pointer. So this is the symbol for pointers. All right, so the next term that we're going to be discussing this spring is what is this? An envelope with an address. So this is an address, and this is pronounced the address of operator. So an address or the address of operator. So all of the areas in RAM have addresses, and all the areas on any storage media will have addresses. Typically it's a hexadecimal number. All your variables in RAM will be stored at a particular address. So we will be dealing with pointers to addresses, and we will definitely use this ampersand, which is Shift 7 on your keyboard, and that's going to be pronounced the address of operator. So address. Okay, so this is a camel and this is a case, and this is going to be called Camel Case. Camel Case is where when I name my variables, my arrays, my functions, I will name them starting with a lowercase letter. All the letters and all the words will be lowercase except beginning in word 2, and each word thereafter will be an uppercase letter. No underscores, no dashes. Camel Case is called Camel Case notation, and I enforce it. This particular slide, for my Python people, this would be a £, which is a inline comment. And for my Python people, this over here would represent by 3 single quotes, and that would represent the beginning and ending of a block quote. This is the beginning and ending of a block quote. When I say I meant comment, block comment. So we know what comments are. They're ignored by the compiler, comments. So I have inline or block. In C, hopefully you all recall that unless you're my Python guys and ladies, all statements in C end in a semicolon. So Python people, you must put a semicolon at the end of every statement if it's a statement, otherwise it won't compile. So semicolon, it terminates a statement. So this slide says something comes before main, and then it says library documents. So what comes before main? And those are called your preprocessor directives, or your includes and your defines. So in Python, we should have been familiar with our import, and import and #include would be synonyms for each other. Python uses import to link external library files, and C uses #include. So my preprocessor directives, because these things occur before the code actually runs, will appear before main. That looks like a fork in the road, or a fork in the road. And this represents the decision statement, And in C, we have the if statement, we have the if-else if statement, and then we also have a switch. So those are our flavors of the decision statement. My Python people had everything but the switch. I think that's some type of design and a bunch of tools. So design tools. Design tools will be used for every assignment unless the assignment specifically says no design tool necessary. And there's a video out there if you're not familiar with design tool. If you're my Python people, you know what a design tool is. If you're my previous C or Java type students, you also know what a design tool is. Language independent. In this class, we're going to spend a lot of time on something called functions. So fx would represent a function, a function, a function. So we're going to be doing functions from A to Z, and we'll look at them various ways, especially when we send or pass things through the parameter list by value or by reference. What you see on the screen now looks like a organizational chart from a company. And that's kind of what it should look like, because that is now called a structured chart. And a structured chart is one of my 4 design tools. And we will spend a lot of time with structured charts once we get in. We will spend a lot of time with structured charts once we get in to writing and using functions. Okay, so the next slide is input, process, output, and again, I don't even think I need to specify anything else there. If you look at the words input, output, input, process, output, we can also consider that to be one of our 4 design tools, and that would be an IPO chart. Bunch of English-like statements, that's your pseudocode, another design tool. And finally, this is a flow chart, and that would be your 4th of the design tools. Wow, this is really a stretch. And then these are a bunch of names. Dynamic memory, major concept of this, major topic in this course. This represents a 1D array, so all arrays have subscripts or indexes starting with 0, ending with size -1, and they store values. Arrays in C are different than lists in Python, and if you're a Python student, you need to watch those videos on arrays so you can get up to speed. It won't be a complete new concept, but it's just different. Most of you are familiar with a 1D array. Well, in this class, we're going to expand upon that, and we'll do multi-dimensional or 2D arrays. A 2D array is nothing more than a 1D array with multiple columns. Up until this point, or up until a certain point in the semester, you will have created variables, created functions, created arrays, stored information, and all that information you've stored is on something called the stack. So these are representing little stacks, and we're going to talk about the stack mainly when we start to leave the stack. So stack is just an area in memory. It's called the automatic memory. The way we leave the stack is when we get into this concept, and this is called a heap. Trash heap. So memory, RAM, is going to be divided into 2 categories, the stack and the heap, or automatic, which is the stack, or manual, which is the heap. All of your code better have a comment header if you want full credit, and in your comment header, I would at least at minimum like you to have your name, the date you wrote your code, and a short statement of kind of what the code's about. Comment header. We're going to end this semester. This is a chain, and these are links, and this is a checklist. So this is a linked list, and that's our last topic for the semester. You'll see when we get there. We will introduce and again, a lot of you may have already known how to use it, but we will use the concept or introduce the concept of the debugger. So we'll spend at least one session on the debugger. I think this is Alexa's echo dot thing, echo, repeat, loops. So this is all about repetition, and we will spend a considerable amount of time throughout the entire semester on repetition. And that's all I have to say about that. Okay, I'm back, and I'd like to just do a little bit of C programming basics. So C programming basics. All of your code is going to have a comment header, and you can either create that with an inline comment or a block comment, but it basically, and we've seen this in my other slide, my comment header is going to have who wrote it, when they wrote it, and a short basics statement or purpose. And I don't care if you use inline or block comments. This would be doing the exact same thing that I did in the previous slide, just using a block comment. /, asterisk, *, everything in the middle is a block comment. Here's my example of my preprocessor directives. Okay, when it comes to preprocessor directives, um, notice this guy right here, pound define underscore capital CRT underscore capital secure underscore capital no cap or underscore warnings. This is for Visual Studios only. This is a command that Microsoft came up with, and basically this turns off the safe commands, the underscore S. If you're familiar with the underscore S commands, great, use them if you'd like. But if you're watching the Archibald videos, those videos were actually recorded before the underscore S commands even came out. Plus, this underscore S is only a Microsoft thing. So I kind of avoid them because you could be writing in any IDE. So the way to avoid them is to put this statement to turn the switch off so that they're not tested for. And we'll see this throughout the semester. Here is stdio. This is including or linking or importing a library for your common input-output functions. stdlib contains some basic useful functions. Some programs you're going to include string.h, for example. This contains all your built-in functions for C. And this last pound define that I have down here, I'm showing you that you can create constant aliases for various commands. So I could write my own function called mypause, and instead of always calling mypause with mypause left and right paren, I can replace that with this alias, and it would just be the capital PAUSE. Notice this is in capital letters, not in Camel Case, because this is a constant, and all constants are written in uppercase letters. These two includes are common in every code you write, so those are going to be your first two includes, and you'll get used to that as we move forward. So after our preprocess directors, what comes next? Well, here's a class role. So in C, as in many other programming languages, the program always begins with the main function. The main function. So it's my guess that main is called main because it's important. So I would say it is important because it's where your code actually begins. So since main is important, since main is where the code begins, when I open your code after your preprocessor directives, the next thing I need to see every single time is your main function. All other functions are written below main because they're not important as main, so main's first. So the rule, the class rule, is main is the first function in every code you submit. So the structure of the program is your comment header, your preprocess directives, and then main comes next. Main is actually a value returning function. It returns an int. So there are different ways to write main, but I like int space main left right paren opening this guy right here. Let's talk about this guy right here. That is a brace, a bracket, a curly brace, or a curly bracket. Notice I gave that like 4 different names. Well, throughout the semester, it's always confusing, especially on an on-site class. Students will say curly brace, brace, bracket, something, and we'll never know exactly what they're talking about. So one of my students about 5 years ago, he said, "Professor Hunchak, that's not a curly brace, that's a mustache." And I thought, what, huh? And he turned one around and put it underneath his nose, and he said, "See, it's a mustache." So if you look at that, you can see a mustache. And ever since then, because I know once I say the word mustache, you know what I'm talking about. So I apologize for using the term mustache, but instead of curly brace, I'm going to call them mustaches, and this way we all know what I'm talking about. Mustaches come in pairs, and what mustaches do is they mark the beginning and ending of a block of code. Houston, we have a problem. What the hell is this about? So we write our functions below main. Visual Studios may crash when it encounters a function name. In short, C does not know the definition of a function that's written below main. So here's my problem. I told you main is first, all the functions are second. Well, in main, if I call a function that's written below main, the program could say, what the heck is this? And it could possibly crash. How do we solve it? We solve it by doing function prototyping. So it's an extra step in C, and some of you are going to hate it, and some of you are just used to it. It's again one of my little rules that you're going to always prototype your functions prior to the beginning of main up your preprocessor directive area. So let's take a look at that. We prototype functions so that when main sees the name of a function, it knows to find the function definition down below main. So how do we prototype? This is right before main. When we prototype a function, we give the function's data type or return type, the name of the function, and then basically just the function's signature. We do not include a mustache. We replace the mustache with a semicolon. So this is called a function prototype. This comes before main, and the function is written below main. So you place your preprocessor directives up here and then main. So here would be an example program. So here's main down here. It's the first thing I see. Here's my comment header. Here's all my preprocessor directives. Here's my function prototypes, and here's main. Main begins here, and main ends down here. Come on, go away. And then down below main, I don't know how I make that go away. I'll wait a second and it should fade away. Go away. Okay, good. Thank you. As you look at that last line, all other functions are down here below main. So all your other functions are down below main. So in summary, all programs start with a comment header. After the comment header comes your preprocessor directives. After the preprocessor directives comes your function prototypes. After your function prototypes come main. After main comes all other defined functions. And all of your functions should end with a mustache and a comment that says what is ending. Okay, this is Dennis. I'm back again, and I made this little slideshow specifically for my Python programmers coming into C for the first time. So if you're a Python programmer, you should be listening and continuing on with this video. If you're a C programmer already, it's up to you if you want to continue here. So some of the differences between C and Python. C requires the main function. Python does not require a main function. At C, the point of beginning is the main function. In Python, it's actually not the main function. Main in Python is optional unless you had me. I made you do it. And the reason I made you have a main function when I had you in my Python class is because when you get into C, when you get into Java, all code begins with main. In Python, there is no terminating symbol at the end of a line of code. You just stop typing. In C, it ends in a semicolon. So you're going to be getting used to these concept of a semicolon because all C statements and then a semicolon. Just remember, all statements or all lines are not statements, and you'll see that throughout the semester. In Python, you have a inline comment, which is the pound, and the pound is the shift 3. And in C, you have a double forward slash. So your double forward slash is your inline comment in C, and it's very similar, the same as the pound inline statement in Python. In C, you have a block comment, which expands over multiple lines, and that's a forward slash pound followed by a pound forward slash. Very similar in Python, it was the 3 single quotes followed by 3 single quotes. So same concept, just 2 different symbols. In C, a block of code begins and ends with a mustache or a pair of mustaches. In Python, a block of code begins and ends with indentation. The good thing about Python is it forced you to indent. The good thing about being forced to indent is use the exact same indenting when you do C or Java or C++ or C#. It's a very good concept. In C, we have the scanf function to get input. In Python, we have the input function to get input. So scanf versus input, somewhat similar, although as you can see, the arguments are quite different. We also have the getChar function to get a single character from the keyboard. So scanf and getchar get data from the user via the keyboard. Input does the same thing. And there's some significant differences. So my Python people, you need to watch the video on scanf. As far as output, in Python we have print, and in C we have printf. And my Python people, you guys are at a disadvantage because you're not familiar with printf. So you need to watch the video on printf. You'll see it's not that much different than print, just somewhat different syntax and a couple little things, but it does the exact same concept. Python does not have data types. All my data types in Python are implied. So you have the implied integers, floats, strings, and chars. In C, C is strictly typed. So we have these keywords, int, float, double, char, and then we also have something called char star. So that's new to my Python people. When we create a variable in C, we must give it a data type. In C, once we give a variable data type, we can't change it. In Python, Python automatically changes data types as the data changes. In C and in Python, we have what's called decision statements. And those decision statements are very similar. In C, it's the if, and in Python, it's the if. Notice one of the big differences in C, there's no colon after the right parenthesis. In Python, there is. So that colon is a Python-only thing. So in addition to that, we have if, and then we have if, else, and in Python, we have if, else. The only other difference, though, is in C, there is an if, else if command, and Python invents the else if as a new condensed word, ELIF. Does the exact same thing. It's just, it's not spelled this way. This is Python. This is the way you do it in C. Now, in C and other languages, basically other than Python, there's something called a switch, and it's the secondary decision-making statement. So a switch is like an if, else, if. But it starts with the keyword switch, and then there's a variable inside of a parenthesis, and that has to be a variable. And based on this value of a variable, if it's a 1, we do the code in here. If it's a 2, we do the code in here. If it's something else, we do the code down here. And if it's not one of these matching cases, we do the code in default. So for my Python people, please watch my video on the switch. Because there is no switch in Python. Not a big deal. We can live without a switch because we did in Python, but it's convenient, especially in menu systems. Python has two types of loops. That's the while loop and the for loop. The for loop in Python uses this range function. In C, we don't have a range function. We do have a while loop, exact same while loop as we had in Python, and the things that go inside of the left and right paren, which would be my conditions with my relational and conditional operators, all of those are the exact same, nothing different. All the logic is the exact same, nothing different. The truth table is the exact same, nothing different. The big difference, though, is the syntax of the for loop, and if you're my Python people, you're watching this, you need to watch the video on the for loop. And then this do while loop. This do while loop does not exist at all inside of Python, so this will be a little new to you. Think of it as a while loop upside down. The condition is at the end instead of at the beginning, and it'll come to you. All right. In Python, we did not have arrays, we had lists. While in C, we don't have lists, we have arrays. Lists and arrays are similar to each other, but then again, they're not. In C, the arrays have some characteristics. All arrays must have a size. In a list, you don't have a size because lists are dynamic. In C, all arrays will have an index. In lists, all lists will have an index. The index is in an array, start at subscript 0, same thing in a list. One of the other main differences between the two concepts is the array in C has a data type, and every single element in that array has the exact same data type. In a list, every element could have different data types. Python's about the only language I know that you could do something that strange. So every element in every array will always contain the exact same data type. Okay? In summary, in summary, C and Python are definitely both programming languages. And all the concepts you learn in Python apply to C. In this class, we're going to take you on a journey into C-specific topics such as pointers, binary files, text files, structs, and dynamic memory. There are many differences between C and Python. C is a procedural language. Python is an OOP language. And I also like to say C is a lower level language and Python is a higher level language. Okay, I think I apologize for a minute there. I left my recording go. So I'm back. And again, what I would like to do now for the remainder of this video section is to show you a little bit of Visual Studios and a little bit of DevC. So here's the icon for Visual Studios and here's the icon for DevC once you get them installed. So I'm going to start with Visual Studios. So I'm going to open Visual Studios and I have Visual Studios 2019, the Community Edition. And I got this directly from Microsoft's website. I went to Microsoft.com, I went to downloads, and I typed in Visual Studios Community, and it gave me this software completely free as a one-time download. Over here are projects I have been working on. Over here is how I create a new project. So see, Visual Studios uses the concept of a project, and I'm going to create my very first project. So I click on Create Project, and the next thing I need to make sure is this says Empty Project, and I click on Empty Project. I say Next, and now up here is where I create the name of the project's going to go here. And then over here is going to be the location on my file system where I want my project to exist. So if I want to change the default location, and I highly recommend you do such a thing, is I'm going to search in my file system a location where I may or may not wish to store document. So for example, I'm going to go into my Google Drive and I'm going to go to Valencia and I'm going to go to Spring and I'm going to go to C, and at the root of C is where I'm going to store this project. So this is going to be at the root of my Google Drive Valencia Spring C programming class. So I'm now going to say create, and I'll wait a second here as C does its thing, as Visual Studio does its thing. And here I am inside of Visual Studios for the very first time. So let's take a look at here. So in Visual Studios, it is set up with the concept of something called let me hit pause. I apologize, I paused for a second so I can expand the window. It's called the concept of a Solution Explorer, and this Solution Explorer, it could be over here, it could be over here, it could be multiple places depending on how you install it and where you like it. So the first thing I'm going to do is this is where my document goes, and notice there's no document there yet. To get to an actual document, I go to my source folder right here. I right click on it like that, say add new item, and now I make sure this says Visual Studios. I make sure this is clicked, and down here my first source document. So down here on this line where it says name is where I actually give it the name, and the name of what I'm going to create is going to go inside of this project folder, which is inside of the path I previously set up. Now here goes the big deal, the big rule, the big rule is do not forget to end it with a .c. If you do not put that dot and that C it will default to .cpp, and .cpp is C++, and C++ is a 100% different compiler than the C compiler. So your code will not run even though you'll think it should run. So that is a big error that students make, and you'll do it even when you know not to, just by accident, because you'll forget. So always make sure .c and then say add. And now this is my blank sheet of paper. Notice the name of my first source document .c. I can see that .c. If I look up there and that says .cpp, I have a problem and I basically have to start over. All right, so if you remember, we are in our IDE for the first time, and if you remember, the first thing that I want you to do is a comment header. So whether you do it in inline or block comments, doesn't matter to me. You're going to put your name, the date you wrote it, I'll bet you don't know this. Today is New Year's Eve. What? January 13th is New Year's Eve? Well, my mother is Orthodox, and if you follow the old calendar, January 13th is New Year's Eve. Huh. Learn something new every day. So you're going to put your name, you're going to put the date you wrote it, and then you're going to put a purpose statement. Make sure you can type a little better than me. All right, so there's my comment header, and you don't have to build like a marquee around it, even though I'm kind of anal, and I do. Sometimes I get extremely anal, and I do this, where it looks just like a marquee in a movie theater. This is your personal preference. All right, so the very first thing I'm going to do in this area now is my preprocess directives. I'm going to do my pound define underscore CRT underscore SECURE underscore no underscore warnings. And if you remember me saying before that this it turns the switch off and stops Microsoft from yelling at you if you forget to do the underscore S or save commands. All right, so I need my minimum of my two includes. Two includes. My standard library and my standard IO and my standard library. So those are the two defaults, and then right in this area, right here would be my prototyping, and since I don't have any right now, I'm just going to say int main mustache comment. So there's my basic program. So for the first time, written by me when I wrote it, a short statement or a couple sentences about it. This is my preprocess directives where I turn off the save commands, turns off the looking for the save commands, kind of what I said here, my two libraries that I have to include on all my code, and here I go. So the very first time, if I want to run this, I'm going to run it by clicking on this green triangle. So I could do this, and it'll run. It's running, 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 and it's done. So there wasn't much happening. That red background was the console window that appeared briefly. Now, if I want to cause that console window to remain on the screen, I can do this various ways. One way is to use this system pause command. Let's take a look at what system pause does. Because it's a statement, it must end in that semicolon, and I'll run it again. So when I run it, it says press any key and continue. Well, where did that come from? That came from this command. That's what this does. It halts execution of the program. Causes the program to halt execution until the user presses enter, and it does that prompt on the screen. So notice I can hit this little icon that I keep hitting, or I can go to debug, and notice that same little shape is here And notice it also teaches me that I can hit F5. So I can hit debug, click here, I can click here, or I can just hit F5. F5 compiles and runs all in one step, and that's just what happened. So I pressed F5 again, I can press F5 again, and again, and again, and again. And I highly recommend after every 2 to 5 lines of code, you press F5 just to make sure everything's good. All right, so here's my function that I'm going to write a quick function. I'm going to write my own pause function. Check it out. It's going to be a void function. It's going to be called myPause. And myPause is going to end here. And myPause is going to do a new line, press any key to continue, and then end with a new line. And what I'm going to do is I'm going to say get char. Let's take a look at what happens when I replace this with myPause. So I'll comment this out, and I'll replace this with my PAUSE, and I'm going to run it. Here it goes. And it crashes. It crashes. And let's take a look and see why it crashed. It says my pause is undefined. It has no idea what this is. You know why? Because I didn't prototype. Prototype, I take the function header, which is this guy right here, copy it, paste it up here, get rid of the mustache, and replace it with a semicolon. Let's run it. Press enter to continue. Hey, it worked. It paused. As soon as I hit enter, it brings me back to the program. So I can use the pause that comes with system, or I can invent my own. That's your personal choice. Mine is a little more generic. It should work on various operating systems. All right, so now, because I'm lazy, I do not like to type the words my pause, left and right paren. What I would prefer to do is not use this at all, but replace this with PAUSE. And I can do that by doing this. Check it out. What I'm doing right here is I am creating a constant. Notice constants are all in uppercase letters, and the constant is going to be the same as whatever I type after the constant. So this and this are aliases for each other. So since I'm lazy, I can now use pause instead of this. I don't gain a whole lot, but watch, it'll work. Maybe. And it did. All right, so here we go. Let's go back into main and let's print the hello world. So this is a most basic of all programs. It just says hello world on the screen. Notice I have a red squiggly. I have an error. Let's take a look and hover over this red squiggly right here. Say down here, here's the error. Expects to see a semicolon. Notice I left the semicolon off up here. Watch the red squiggly down here goes away as soon as I press the semicolon. Boom, and boom, goes away. All right, so this should now say hello world, and then press any key or enter to continue underneath. Let's make sure that works. Hello world, ... press enter to continue. Let's do it, and we're back. Okay, I'm going to do this again now. Watch, check it out. I'm going to highlight all of this. I'm going to copy it with a Control-C, and I'm going to go down here. I'm going to go and leave this in the background, but I'm going to use Dev C this time. Check out Dev C. So I'm opening DevC for the very first time, and here's DevC on the screen. Check it out. Here's DevC on the screen. Notice DevC is a lot more streamlined. I say File, New, Source File, and I'm in my source document. I'm going to paste the code from the Visual Studio's program, and here's my DevC program. Notice DevC is color-coded just like the other, but notice this time my code has not been named. So when I go to run it, and this is how you run it, it's either compile and run, this icon, or F11. So in Visual Studios, it's F5. In DevC, it's F11. When I run it for the very first time, what happens is this pops up and it says, hey, what do you want to name this? So I'm going to name it my stuff.c. Do not forget to put the .c on the end. Make sure you know where it's being saved and then hit save. So now this is called on my desktop, my stuff.c. If I run it, and there it is. Hello world, press any key to continue. So the exact same code in two different environments works. And by the way, notice one was blue, one was red. We're not going to really get into it, at least for now, but I can change the colors if I want without any issues. All right. So now, working in DevC instead of Visual Studios, I'm going to get rid of that comment and I'm going to create a couple variables. I'm going to create a variable of type integer. Let's call it value 1 and value 2. And then I'm going to create another one called result. So there's three variables, value 1, value 2, and result. Notice I did those two different ways. I did two on one line and one on a standalone line. So I can create multiple variables with the exact same data type by separating them with commas, or I can put everything on its own line. Now, one of the things I did not do is did not default or initialize my variables, which I truly highly recommend you do each and every time. So to initialize, I say assign it a value of 0, which is the standard initialization for an integer variable. And this is just being safe. So there's my variables, and I'm going to ask the user for a value. Please type in an integer value. So that's a prompt on the screen. And now I am going to get that value. And what I'm going to do is I'm going to get a placeholder for an integer. So the first part of my scanf before the comma is inside of double quotes is a %, which says placeholder, and then a single letter, either I, F, I guess I lied, LF for long float, which is a double, C for char, or S for string, followed by where I want the value to go. So I want it to go in value 1, and if that's the case, I'm going to say printf you entered some integer. Let's take a look at this printf statement. It's going to say you entered some integer. What integer? Value 1. Python people, that looks similar to the Python with the mustaches and the colon and then a placeholder for a value. So it's very similar. And let's watch this crash. So this should not run. At least I hope it doesn't. Let's see what happens. So when I run it, here comes my prompt. Please type in an integer. I'll type in an integer and DevC is very forgiving. It did not crash. Let's go back to Visual Studios and do the exact same thing. Check it out. Let's do the exact same thing in Visual Studios. So I'll just copy this whole main and pop it into Visual Studios. So let's go into here and let's copy this and paste it over top of this main. So the exact same code, Visual Studios, I'm going to run it. Here comes my prompt, type in an integer, and there's my crash that I was looking for. So notice one IDE is more forgiving than the other IDE, but this is what I really expected. I expected this runtime error, and let's talk about why I got this error. And why I got that error is I have a memory issue here. I am trying to store the value that the user typed. I don't want to store it in a variable called value1. In C, we like to use this word. Put it in the address of the variable for value1. The address of, remember my slideshow earlier, the address of. So in my scanf, 95% of the time, I'm going to need this address of operator in front of a variable. Let's run it again. Same code with that ampersand in front of it. I type in a number, and it doesn't yell at me anymore. Okay? It does not yell at me anymore. I'm going to do this one more time, make sure it works. Okay. Now, a new issue occurred, and we'll talk about that here in a minute. We'll talk about that in a minute. And that was what happened with this pause. What happened with this pause. Let's go back over here and notice I can put this address of here, just like I did before. And I'm going to run it. And it says you entered 666. All right. So if I want to get the value for two variables, I could prompt them again. And this time I could store it in the address of value 2. And then I could do math if I want. And that's no different between Python or C or any other language. Just remember that semicolon on the end. And now my output, here's what I want my output to say. Let's just say first number plus second number equals some third number. So that's what I want my output to look like. So I'm going to make that happen like this. Check it out. And again, this is the last thing I do because this video is getting to be an hour now, which is what class is supposed to be. So here we go. I'm going to say some integer plus some integer equals some integer with a new line. So hopefully you would agree that some integer plus some other integer equals some other integer. That makes sense to me. Oops, that's supposed to be an I. And this, the heck? Okay, that's what I wanted to see. This is the end of my format string. So my format string is the first part of a printf statement. After the format string, for every placeholder I have in my format string, I need a value in the value list, and my value is going to be value 1, value 2, and result. First thing, value 1. Second thing, value 2. Third thing, result. So these placeholders line up in position with these values. This guy goes over here, the first one. This guy goes over here into the second one, and this guy goes over here into the third one. That's how they line up. Let's see it run. So I type in a number, 5 plus 11, 5 plus 6 equals 11, and that's the end of that. And when I say that's the end of that, I'm going to say that's the end of that. So I'm going to stop with this video, and I'm going to tell you we have a long way to go, but we have a good while to get there, so we'll be fine. So in summary, my Python people, you need to do a little bit of extra work, not a whole lot, you'll be fine. My C people from COP 1000, you still need to do work. A lot of you, I'm sure, have already forgotten everything you ever taught, so you too probably need to be watching these videos. I apologize again about missing you yesterday on Tuesday, January, what was that, 12th. Yeah, Tuesday, January 12th. I will see you next Tuesday, and I will also, if you do any activity that's due this week and you need to, so you're not a no-show, I'll give you credit for being there yesterday even though you weren't. All right, have a good day. See you Tuesday.